in this proof, we want to prove that triangle PQR is congruent to triangle RST. And the given information here is we've got two segments that are congruent to each other. We also have that R is the midpoint of PT. And so we're going to focus on this definition of midpoint to kind of make that the focal point of the proof to help us prove these two triangles congruent. So it's always a good idea when we're looking at this given information to pick up on keywords, because these keywords help us pick out the reasons when we start writing our steps in the proof. So the first step in any proof is to state the given information. So I'm going to go ahead and insert the given information into the proof. And then I'm going to go ahead and deal with the whole concept of a midpoint. So the midpoint, point R here, refers to the fact that this point is in the center of this long segment. So that being the case, we know we have to deal with a statement involving segments and calling segments congruent to one another. And so if this point splits this long segment into two equal parts, then we know their two parts are the congruent pieces. So we're going to go ahead and set up a statement that says segment PR is congruent to segment RT. So segment PR is congruent to segment RT. And the reason is the definition of a midpoint. So somewhere, there it is, definition of a midpoint. And then it references where I got that information. So where I got that information is from step 3. Okay, and so now what we have is we have 3 segments that are congruent to 3 other segments in a different triangle. And that's enough information to call these triangles congruent. So I'm going to go ahead and insert the congruent statement. And the reason here is side, side, side. And the justification for choosing side, side, side comes out of steps 1, 2, and 4. So I'm going to go ahead and cite where I got that justification. And then I can go ahead and submit this proof for being checked.